microbes, and then actually they lock the carbon inside the soil as well. So this is our result. You can have a look. So soil organic carbon, we are able from 0% microalgae, which is 0.45%, we're able to increase about 3 times using microalgae. So what does this mean for people that do farming? We are able to increase the soil fertility because higher rich carbon actually enhance the growth, and the plant growth as well. So what's next? This is what we call soil organic carbon, soil organic matter, meaning that by improving this about 5 times, you're able to improve the structure and also the pH as well. So meaning that it's able to stimulate the plant growth. Because plant like us, they have hormones. So us is just like human hormone, but plants they have we call phytohormone. So actually able to stimulate the plant, the roots as well, making it more easily to absorb nutrient. Okay, this is our implementation. So first, we'll help you to install and cultivate microalgae at your site. Then we'll teach knowledge transfer. We'll teach you how to actually apply it. So we'll go according to whatever practice you have. Then we see how we can improve and fit into your schedule. So we can do soil drenching around the plant, and then also foliar application as well to relieve. You can see this is actually a durian tree. So what we do is that we found that this durian tree, particular tree, they have problems because this is a 4-year-old tree. It looks pretty tiny. That's why we are there to help them to improve that. As you can see, once we apply, you can see new shoots emerge because they haven't had anything for 4 years. That's why we tried it. So this is actually applicable more to industrial-wise. So microalgae, not only you can actually do sustainable regenerative farming, you can actually use it to capture flue gas from the palm oil industry. Meaning that let's say you have biomass waste, you do the biomass boiler, and then to get the electricity, and then you can see that from the exhaust you actually generate a lot of CO2. So what we do is we can actually implement microalgae system. We channel the flue gas that it can absorb while growing, because they are plants basically. They are able to do photosynthesis, absorb the CO2, and give you oxygen as well. So what do you actually do with the biomass once you grow the microalgae? You can go back into the agriculture, aquaculture, and even biofuel. Biofuel, because if you have excesses of microalgae, you can actually try to do biofuel. Because it's a form of carbon cycle. So you capture carbon, you make it back as a fuel. So I'll give you a case study. This is TNB. Okay, as you can see, TNB is actually running the research as well. So they are building a new plant in Negeri Sembilan in Peninsula. So where they are actually using coal to generate electricity. So they actually put microalgae as a form of flue gas capture. So it meaning that this is a proven technology. You can see that that's how they do it. So not only you can actually capture flue gas with benefits to the environment, you can actually use it in a regenerative agriculture as well. So come to our next problem statement, organic waste in landfill. This is not just normal waste, it's just your food waste, your agriculture waste. So for us, we have another technology to actually solve this. So human, what we do is, after eating, we love food. Obviously we love our prep panel this morning. We love the nasi lemak, we love the laksa. I think I was just told Tawau has a very good soto. Is it soto?
Yeah.
So we love food. But sometimes when we finish food, we always leave some leftovers there. So what happens to the leftover? We'll put it in a bin, it goes to the landfill. What happens in the landfill? Bacteria will actually degrade the food waste, and then it will create methane. They will release methane gas. Methane is about 25 times CO2. It means that we are actually damaging the environment as well. So what we do is, we are using these guys, black soldier fly. In Chinese, you might know it as a 黑水门, but this is basically what it looks like. So basically, we are using this as a form of food waste or organic waste reduction. So we can actually feed your food waste or agriculture waste to these guys. Even let's say your pomade, your decanted cake, your EHB, they can actually eat it as well. Provided you need to do through the fermentation process and then feed it to them. Okay, this is what we do, a circular economy. So you have your farmer, crop plantation, F&B chain. So what you do is you sell your food to your consumer, and or even in central kitchen, you have your processing food. So what we do is we collect all this waste, we feed it to these guys. Then you get BSF larvae, which is the insect, which is a very high protein. And then you have a BSF thrust, which is excrement, that can actually go back as a fertilizer. And the larvae can actually feed your chickens, your fish. It will be a very cheap alternative because it goes through the waste reduction. So, wow. Okay. Alright, okay, no worries. So, as you can see, it's a circular economy. Okay, let me show you some larvae of the actual wood. So, this is our larvae. Okay, let me move to the next one. Okay, as you can see, this is actually the thrust, which is the excrement. As you know, but in agriculture, you often use chicken manure, cow dung as a fertilizer. For BSF, they can do the same as well. Let me try. So, okay, this is all the excrement. We call it thrust to make it nicer, sound nicer. Okay, you can see?
Yeah, I know. This
is how we feed it. Okay, you can see we feed it to the fish. The fish loves it. It's a very high protein. It's about 46% protein. And then the chicken and ducks, they love it.
Wow.
Because for them, the more high protein means they can grow faster as well. And I have to mention, it looks maybe disgusting for someone, but they are actually high in omega as well. They have the omega 369. So imagine your chicken egg. So your chicken, after eating this larvae, they actually give you carotenoid and high omega as well because they have. So whatever you feed the larvae have, it transfers to the chicken and then it transfers to the egg. So meaning when we human we eat also, we get benefit from it. Yes. Yes. Actually in Thailand, people are eating insects. So in Malaysia, we're not that forefront. Myself, I had eaten them before. So you deep fry, I wouldn't say deep fry, you fry them. So it tastes like a bit nutty flavor. It tastes like peanut. Yeah. Okay. Alright. So this is what we do as well. We do knowledge transfer. For us, we are not a manufacturer. So what we do is we believe in social impact community as well. So what we want is to do knowledge transfer. We do, for this one, we actually won a UK grant from engineering, Royal Academy of Engineering, UK. So we're doing, they call it a frontier champion. So what we do is we knowledge transfer to community where they can actually do their feed. So they no longer need to buy feed from the big manufacturers, less cost for them. So we also do STEM. So we teach kids how important is it for circular economy. Kids actually love to play with the larvae. Okay, this is the whole process. As you can see, we do microalgae, we do BSF, and now the whole sustainable agriculture. Okay, this is part of our process as well. We have a green TT Green ESG reporting system, so we use international standards. Automation, I won't go through too much. So this is an example. We have a AI tool to do data collection, IoT, which can actually integrate the system directly from your meter to your reporting. and also one of our ESG reporting as well. Okay, why now? Why are we doing all this sustainable? Because let's say for farmers, for companies, why are we doing all this sustainability? For a lot of people, they think it's a cost for you to actually do all this sustainable because you have to do more extra thing. But for us, it's actually an opportunity. Because imagine if you want to expand, you need funds. Government these days, they are actually helping companies that have sustainability. So they want you to go green. Because what they're doing is, as you see, we came up with the National Climate Change Policy, which have the reporting. So all the public listed company has to go through all of this. They have to report their ESG report, and which is the International Financial Reporting Standards. Then, on the budget day, October 18, they have announced they're going to do carbon tax, meaning for the first industry, carbon, the iron and steel and energy has to pay tax on their carbon emission. And then on your left side, you will see Article 6, Article 6.4. This is a Paris Agreement for the whole world. About 180 countries signed. Malaysia is one of them. We had committed to reduce our carbon emission by 45% by 2030. That means all companies will have to be involved. That's why they ask you to do all this reporting, reduce your carbon. But how can we actually benefit from it? We can actually build carbon projects. So this is us. So developing a carbon project is not only a two-person job, it's not just you and me. As you can see, Atoz is in the middle, we're the project developer. So we'll go through the landowner or farmer or whatever innovator. You'll be part of the project owner. So when you have an agreement, you want to do carbon projects, then we will actually approach Vera. Vera is one of the carbon standards. So once we have that, we actually get our project consultant, Deloitte, the big four auditing firm. So what they do, they don't just do consulting, they do carbon audit, meaning that we will take all your carbon emission and check whether our project can actually generate enough credits to actually offset to generate carbon credits. Then after that, we'll go to the validation and verification part. This is actually help you to verify your methodology, meaning that all your data, the ones you say you're doing it, you're actually doing it, then they help submit to Vera. So in all these things, we will also have local academic institution. Why do we have it? Because we want them to come in as a third-party review. So meaning that they will have a scientific backup on whatever you do. Let's say for Vera, once you go into validation, you have this public comment for 1 month. So anyone that do not agree with you, they will go out and say, hey, I do not agree on this because your methodology, you're not scientifically proven. This is where we have economic backup. The professor will come up and say, okay, we have all this scientific data, this is our proof. Then what do we do with project adopters? So for most project developers, what we do is, we do not want farmers or agriculture land to actually give money, because we believe that in helping them to do sustainable, they should get reward for it. They shouldn't put any money up front. So that's why we go to project adopter. Who are they? They are big companies, let's say like Petronas, oil companies, Shell, BHP. So why do they want to do this? Because 2026, they had to pay tax, carbon tax. So instead of doing that, they will actually help to fund the project, where in return, they will get some credits to offset that. Means that are paying a lesser levy. So for us, we rather the big companies to support all the farmers. So this are the potential of carbon projects in Malaysia. So this methodology is based on Vera. So for agriculture land, let's say durian, palm oil, avocado, you can look at VM0042, which is improved agriculture land management. All of this is in public domain. You can go www.vera.org. All this in public domain. So what we want is actually to spread the awareness saying that if you want to do carbon projects, is actually better for you to do according to the standards. Okay, so projected timeline. So we are looking at all these things. So I won't go through too much about the process, but you can look, in the end, you can go the global market and sell it. Cold climate is Hong Kong, climate impact is Singapore, BCX is Malaysia, and TT Green is one of our market trading places, which is also globally. So all these takes time. So for us, the projected timeline to actually do a carbon project is about 2 to 3 years. So it's not like you can do it in one go, because all the data needs to verify, needs to validate. So how do we actually collect all the data? This is some of the equipment we'll be using. Soil gas flux, so meaning that we are measuring the emission from the soil itself. Carbon nitrogen combustion, so we actually take soil sample, then we actually see how much carbon is it. And then we do remote sensing and LiDAR. So this is roughly, let's say if you have an oil plantation, we'll be using the methodology of 042 and also 47. So if you want to increase your carbon sequestration, you can actually plant more trees, make it like an agroforestry. So this is an example of the carbon tax in the world. So we can see the blue color one is actually ETS. ETS is another form of carbon tax where emission trading system. So you have a certain quota you have to limit. If you exceed that, then you have to buy carbon credits to offset it. Then you have carbon tax, which is relatively straightforward. They just tax you on whatever emission you have. So the trending. So we can see that it might be too small to look at. I'll just give you a straight example. Singapore has carbon tax. Last year was 5 Sing dollar per ton. This year is 25 Sing dollar per ton. 2025 to 2030 is projected to be 50 Sing dollar to 80 Sing dollar per ton. So every ton of emission, all the companies have to pay for it. So this is our finding. We can see this is all companies except Petronas. So you can see they spend about 2 billion every year just to buy carbon credits. So you can know that the funding for carbon credits is actually a lot. So these are the bigger companies that actually buy carbon credits to offset. I think Apple, everyone knows about it. Microsoft, Meta, Amazon, all of them are buying carbon credits to offset their emission. Okay, Vera. So why is this so important? You can see the share of the gold credit. Vera is about 68%, about 70. Gold standard is about 20. So the whole world basically is using these two standards. Why this is important? Because you do carbon credits without this standard, you are unable to sell it. No companies won't want to buy it because they're not popular. So even you have a, let's say, carbon project, you don't use this standard, you are unable to sell because you wouldn't be able to offset it. So market acceptance, currently in Malaysia, Bursa only accept Vera. I think end of this year, they'll accept gold standards as well. Then you have Singapore, they only accept Vera and gold standard. Hong Kong also Vera and gold standard. So basically, if you look at the common one, it'll be Vera. That is why we are using the carbon stack from Vera. So this is part of the compliance credit. So let's say you have credits from Vera, they are able to do CORSIA, so which is the airline adopted. So airline will ask you to buy carbon credits in the near future. If you travel by AirAsia, they will ask you, okay, we need you to buy carbon credits to travel because you want to reduce that footprint. By having carbon credit done by Vera, you can actually offset that as well. So this is another example of carbon project, which I mean Tawau, you have a lot of mangrove, wetland. I believe Tawau is actually quite suitable to do carbon projects. So if you want to know more about carbon credits, Atoz Microalgae can actually have a podcast. It's not done by me. We have people doing podcasts. So if you go Spotify, you search Atoz Carbon Cycle or scan this barcode, you can actually listen to our podcast. We explain more in details what is carbon credit, what is carbon projects, and those things. So this is our past what we done. Application, we have vegetables, trees, chickens, and also we do corporate events as well. So we've been to a lot of major sustainable events. So example of Atoz Microalgae, so we actually offset our event as well. So we have retire credits from Vera to offset event, making it the event will be lesser emission. So this is practically what we have. I mean, I think 3 days ago, we are in the Chinese press saying that what we've been doing. And then we won also one of the top 10 in the Selangor Accelerator program. So, and also we won the Gold Award for engineering